Okay, lesson 4. So now we are working on finding angle measures. So again, most of this will be review except now that we're working in radians as well. And that we are working with the reciprocal functions and not just the primary trigonometric ratios. So the instructions that are given here are for the other style of calculator. So you guys can find this in your, I think it's called your trig menu. And then you know that you have the inverse functions that have that little -1. Looks like an exponent, but it's not there. Again, you need to make sure you're in the correct mode. If you're looking for the angle in degrees, make sure you're in degree mode. If you're looking for the angle in radians, make sure you're in radian mode, or calculate it in degrees and then convert it to radians. But we're going to work in degrees when it wants us to and radians when it wants us to, just for the examples. So example 1, complete the following to solve cos theta equals -0.5, where theta is between 0 and 360. So whenever we're doing these, it's best to start by figuring out what quadrant you're going to be in. And there's usually 2 answers that are possible. So we know that cosine is negative. Well, cosine is negative here and here. So that means our answers are going to be in quadrants 2 and 3. The reference angle is what we're going to calculate. So we're going to calculate the cos inverse of 0.5. We're just going to put in the positive one because we're accounting for the negative by picking our quadrants. And this gives us 60 degrees. So this tells us the reference angle is 60. So that means in both of these cases, this is 60 and this is 60. We're 60 degrees away in either direction from the x-axis. So in quadrant 2, this angle would be, well, all the way here it'd be 180. We're 60 degrees short of that. So it'd be 120 degrees. And in quadrant 3, we're 60 degrees past 180. So here we go 180 plus 60, giving us an angle of 240. So if we're asked to solve this equation, we're going to answer theta equals 120 degrees and 240 degrees. So make sure that you always give all the answers. One answer isn't enough. Given that sine theta squared can also be written as sine squared theta, solve the equation sine squared theta equals 0.5. Well, this just means we're squaring the whole function, so we can square root the whole function. Since we are introducing the square root to the right-hand side, we need to consider both the positive and the negative square root here. So what quadrants are we going to be in? Well, we need sine to be positive or negative. So we're going to actually have answers in all 4 quadrants in this case. So now we're going to use our calculators to come up with the reference angle, or you could use your special triangles as well. So we're going to calculate the inverse sine of square root of 0.5, which gives us a reference angle of 45 degrees. So that means in every case here we are 45 degrees away from the closest spot on the x-axis. So what do those angles equal? Well, the first one's easy. It's 45 degrees. In quadrant 2, we're 45 degrees short of 180. So that's 135 degrees, or 180 minus 45. In quadrant 3, we're going to go 180 plus 45, which gives us 225. And in quadrant 4, we're 45 degrees short of 360, which gives us the angle of 315. Okay, well, what if we're working with the reciprocal trigonometric ratios? So again, I believe your calculator has these keys, but I'm fairly certain they get locked out for the diploma exam when we're in press to test mode. So we do need to follow what it says here for the calculator. So to solve cotan of x equals root 3, we can rewrite this as tan of x equals 1 over root 3. So what we're really trying to solve here is the tan of x equals 1 over root 3. Okay, well, where is tangent positive? Tangent is positive here and here. So we must be in quadrant 1 or 3. We then find our reference angle by going to our calculator and typing in tan inverse of 1 over root 3. This tells us our reference angle is 30 degrees. So this must be 30 degrees, and this must be 30 degrees. Coming up with our answers then, well, quadrant 1, that answer is pretty simple. It's just 30 degrees. Quadrant 3, we've gone 30 degrees past 180, so that means our answer is 210. Example 4, determine the measure of x to the nearest degree where x is between 0 and 360. So this is asking secant. So remember, that's the same as saying cos of x is equal to 1 over negative 1.2631. So let's sketch this. So we need cosine to be negative. Okay, well cosine is negative here and here. So we must be in quadrants 2 and 3. We then type this into our calculator. Inverse cos, sorry, we'll type in just the positive number, otherwise it doesn't give us the reference angle. So we type in 1 over 1.2631. And this tells us our reference angle to the nearest degree is 38 degrees. So what are our solutions then? Well, in quadrant 2, we're going to go 180 minus 38 to get our answer of 142. To get the answer from quadrant 3, we're going to go 180 plus 38, which gives us the answer of 218. B, cosecant x equals 2.45. This is the same as saying sine of x. Sorry, I guess I should use the same variables there. Sine of x equals 1 over 2.45. So where is sine positive? Sine is positive here and here. So now I can go to my calculator. Sine inverse of 1 over 2.45. This gives us a reference angle of 24 degrees. So this is 24 degrees. This is 24 degrees. So what are our solutions? Well, the answer in quadrant 1 is just equal to the reference angle, so 24 degrees. Quadrant 2, we're going to go 180 minus 24, which gives us an angle of 156. Example 5. Determine the measure of theta to the nearest whole number where theta is between 0 and 360. So these are the special cases. So where is cosine equal to 0? Well, sorry, if you type in this, inverse cosine equals 0, it's going to tell you that the reference angle is 90 degrees. Okay, so where is cosine equal to 0? Well, what does this mean? This means that the opposite side, sorry, the adjacent side over the hypotenuse, when we divide those, we get 0. Where is the adjacent side equal to 0? It has to be the adjacent side that's equal to 0. That's the only way we're going to do a division and get an answer of 0. Well, the adjacent side is equal to 0 when there is no x value here. So we know if I have a triangle, the adjacent side is always the one on the x-axis. Well, where are we going to have no adjacent side? If we're on the y-axis, we have an x value of 0, so that means our adjacent side must be equal to 0. So our answer here would be 90 degrees and, sorry, 270. So at those points, this x value is equal to 0. It's like it's compressed. We can still calculate the other two sides. They would both be equal to the opposite side. The hypotenuse and the opposite side would be equal, but we can't, but the adjacent side is 0, so it equals 0. B. Between 0 and 360, where is cosecant undefined? Well, for cosecant to be undefined, that must mean we're dividing by 0. So what does that mean for sine? Well, we know that cosecant means we take the hypotenuse and divide by the opposite side. We know the opposite side must be 0 if this is undefined. So sine theta equals 0 means that our opposite side must be 0. So what does that mean? Well, that means our y value must be 0. So we must be on this arm or on this arm to have a y value of 0. So what are our angles there? Well, it can be 0 degrees. It can be all the way over here at 180 degrees. And can be all the way back to 360. So see how here it says we're including 0 and 360, so that's why we have 3 answers here. Sometimes they'll just say greater than 0 but strictly less than 360, and then we only consider the 2 answers of 0 and 180. Okay, well what if we're working in radians? So the process really stays the same. You can always work in degrees and convert back the best you can. Or you can use your special triangles or your unit circle if you've memorized it to come up with your answers. So again, this gives pretty specific calculator instructions for the other calculator, so we're just going to skip down to the example. Really, everything's working the same, except that we're now in radians. So we will want to be in radian mode when we type these things into our calculator. So we're just rounding to the nearest hundredth here, so we can just use our calculators. We don't need our special triangles. We're going to go about this process in the exact same way. So cosine is negative where? Okay, well cosine is negative here and here, so we're going to be in quadrant 2 or 3. We're going to type in, cos of 0.5. Make sure you're in radian mode now because we're asked to answer between 0 and 2 pi, so that means we're considering all 4 quadrants. When we type that in, we now get a reference angle of 1.047. So that tells us that this angle is 1.047 radians. So what are our solutions then? Well, remember when we're in radians, this is equal to pi, not 180 degrees. So to find this arm, we're going to take pi minus 1.047. To find the other angle, we're going to go pi plus 1.047, which, since it asks for the nearest hundredth, we're just going to punch into our calculator, and this gives us 2.09 and 4.19. This is in radians. You don't need to write a unit for radians, so you can just leave it like that. Cotan. Well, the first thing we want to do is, let's rewrite this as tan. Now, it's only looking for values between 0 and pi, so it saves us a bit of work here. I only need to consider quadrants 1 and 2. Tan needs to be negative, so that tells me I'm going to be in quadrant 2. I don't need to consider those because it just wants answers between 0 and pi. So now I'm going to type in tan inverse of 4 over 5, making sure again you're in radian mode. Gives me a reference angle of 0.675. So this is 0.675 radians. So to get the answer, I'm going to go pi minus 0.675, and that's going to give me an answer of 2.47. So if you really dislike working in radians, especially if it just asks you to round it to the nearest hundredth, you can work in degrees and convert back to radians at the end. Okay, the exact value part gets trickier. So there is kind of a calculator hack you can use, or you can work with your special triangles in the unit circle. Here's the calculator kind of hack. So we can determine the solution as an exact multiple of pi radians using the procedure below. Divide the reference angle by pi and convert the answer to a fraction. This fraction is the multiple of pi radians. So there's an example down here. They found the reference angle would be 1.047. They divided by pi, changed it to a fraction. Then you'd put pi back in a second. So this tells you that your reference angle is pi over 3. So to determine the exact solutions to cos theta equals negative 0.5, complete the following. So same thing as before, we're going to decide our quadrants first, so that when we go to our calculator, it just gives us our reference angle. We did this procedure to get 1/3, which means our reference angle is pi over 3. So in quadrant 2, that's where this would be. Cosine would be negative. Our answer would be 2 pi over 3. So again, when you're punching this in, you could type in 1 minus 1/3. It's going to give you 2/3. Put the pi back in. In quadrant 3, the rotation angle is pi plus pi over 3, which is 4 pi over 3. Not all solutions can be given as exact multiples of pi radians. If the reference angle divided by pi does not convert to a fraction, then the solution cannot be written as an exact multiple of pi radians. So this isn't a foolproof system, but it does help. Or you can use your special triangles or your unit circle and the sine hand trick, which I'll show you as well. So in each case, determine the exact values of theta in the interval 0 to 2 pi. So I'm just going to sketch our special triangles here to help us. So remember the 1 here, this angle is 60 degrees, which is the same as pi over 3. This angle is 30 degrees, which is the same as pi over 6. This side's 2, this is 1. Pythagorean theorem tells us this side is root 3. Then we have our second triangle, which has reference angles of 45 degrees, which is the same as pi over 4. And we have side lengths of 1, 1, and root 2. So sine theta is 1/2. So we're going to start the same way. What quadrant are we in? Well, sine is positive here and here. Where is the sine 1 over 2? Well, the only triangle I have 1s and 2s in is this one. If I'm saying opposite over hypotenuse, which I need to do for sine, that tells me my reference angle is pi over 6. So I know that my angle here is going to be pi over 6. Now that's the reference angle. I still need to calculate the whole angle, or the terminal arms of each angle. So the one, well, in quadrant 1, that one's easy. It's pi over 6. In quadrant 2, remember all the way here would be 6 pi over 6. We're 1 pi over 6 short, so it must be 5 pi over 6. B, secant theta is negative root 2. Well, this is really telling us that cos theta is negative 1 over root 2. Well, where is cosine negative? Cosine is negative here and here, so we're in quadrants 2 or 3. Now let's go to our special triangles. The numbers 1 and root 2 only appear in this triangle. Cosine is adjacent over hypotenuse. So adjacent over hypotenuse, your reference angle of pi over 4. Of course, this is an isosceles triangle, so you can look at it as either of those angles. But this tells us that our reference angle is pi over 4. So if we're looking here, half a rotation is 4 pi over 4. I need to go back a pi over 4. So one of my answers is 3 pi over 4. For the next one, I need to go forward a pi over 4, which is 5 pi over 4. Last one, where is cosecant undefined? Well, remember, cosecant means we divided it by 0. Cosecant is the hypotenuse over the opposite. So that means sine must be 0 over the hypotenuse, which is just 0. Now this is a case that is not in our special triangles, so we can go to our calculator, or we can think of it like we did a few minutes ago. So where is our opposite side 0? So remember, this is our triangle, always on the x-axis. The opposite was our y value. So wherever y is 0, sine will be 0. Now again, we're asked for answers between 0 and 2 pi. Well, at 0 radians, our y value is 0. At pi radians, our y value is 0. And after a full rotation at 2 pi radians, our y value is 0.